So hi everyone, welcome to the Qualifier Week 1 content. So in this particular video we are going to cover all these important topics from Week 1. So these topics are natural number and their operations, rational number, real and complex, set theory, property of set, and then word problem. So we will have more than 10 problems based on set theory. So in this particular session we are going to cover a very brief idea about all these topics, and then we will go to these word problems and solve each problem one by one, starting from very basic concept will be used for question number 1, and then the toughness will increase from question by question. So starting with natural number and their operation. So natural numbers are basically the counting number. So counting number start from 1 and it goes up to like 1 2 3 4 5 6 and so on. So basically in this particular course the professor included natural 0 in the natural number, and it was denoted by n naught. Okay, so you have to remember a bigger n, and the notation is n naught, although they wrote in most of the part of the video. So you have to remember it that for this particular course 0 is included in natural number. Okay, so keep this thing in mind. So now moving to the operation. So there are four mathematical operation. So the first one is addition, second one is subtraction, and fourth one is um, division. So for addition, if we add two natural numbers it will give natural. When we subtract two natural number, so it will give either natural or either integer, although we do not have idea about integer here, so but we will get about this in a very short span of time. And multiplication, so multiplication of any two natural number will give natural, and division may give natural or rational. So we don't have idea about integer and rational here, although you may have studied from the lecture, but we will restrict ourselves from integer and rational till now. So what are integers? So basically let us assume two natural number, that is 1 and 10, and subtract 10 from 1, so it will give -9. So -9 is not an natural number, so it is a integer. So basically integer is extension of natural number in the left. So particularly 0 1 2 3 4 and so on. So in the on the number line, so all the numbers including 0, and from right of 0 or in this direction, that is uh, right word, are natural numbers. Okay, and from 0 to the left position, all the numbers which lies in the left word of 0 and plus right word of 0 including 0 are called integers. Okay, so particularly from 0 to all these points are natural, but from here minus infinite to plus infinite are called integer. So now we have idea about integer also. So additional, we will restrict ourselves from rational. So first we will go through some important topics or some. So first we will go through some basic idea about quotient, remainder, and what is mean by factor. So what is QUOTINT? Quotient, remainder, and that is factor. Okay, so what is quotient? Let us assume we divide 24 by 7, so it will give 3 as quotient and remainder will be 3. So what we'll do here is we can write 24 divided by 7 as 3 and 3 by 7. So basically here 3 is quotient and 3 is remainder. So it may be confusing, so let us assume another number, that is 29, and it is divided by 7, so it will give 4 as quotient and 1 as remainder. So particularly remainder is also written as 29 modulo 7, so it will give 1. So basically it is used in Python, so we restrict ourselves from using percentage sign. So in mathematics it is written as 29 mod 7, so it will be equal to 1 here, and quotient is 4. So we have idea about modulo here, so that means remainder, and so we know what is quotient, remainder. So now moving to the factor part. So factor means let us assume any number that is 4 divides 12, so it is written like this: 4 divides 12 means 12 modulo 4 will give 0, and its quotient is 3. So any number that is a, if it divides b, that means a divides b, so it means b modulo a is equal to 0. So any number a that divides b is called factor of b. So let us assume a number 12. So how many numbers will divide exactly? How many numbers will divide 12? So we will write in the factor form. So 12 may be written as 1 times 12, 2 times 6, or 12 may be written as 3 times 4. Okay, so here we can write 1 12, 2 and 12, 3 and 12, as well as 4 and 12, 6 and 12, and 12 as 12. So 1 is factor of 12, 2 is factor of 12, 3 is factor of 12, 4 is factor of 12, 6 is factor of 12, 12 is also factor of 12. Okay, so we know what does it mean. So this is the representation of a divides b. So here 1 divide 12. So there is a very basic concept here. So first we will understand rational number. So rational number is in the form of p by q. So you may have idea about it, and p by q is such that GCD, that means common divisor, greatest common divisor for both p and q is equal to 1. So let us assume any number that is 4 and 10. So the GCD for 4 and 10 is so it may be written as 2 times 2, and it may be written as 2 times 5. So here both 2 is common, so it is 2. So we will divide numerator and denominator by 2, so it will give 2 by 5. So it should be equal to p by q. Although we can write 2 by 5 as 4 by 10. So when we have to compare any number, addition, subtraction, or anything that can ease our effort, then we will use 4 by 10, and it's a multiplicative. This is the only idea about rational number. So we don't have to study much about rational number. So now we are moving to prime number. So what a prime number is, so we should have discussed it in fact, but we should have discussed prime number there, but what can we do here? So prime number is basically those numbers which have only 2 factors. Let us assume any prime number a. So a will have only 2 factors, that is 1 and itself a. So let us assume any number that is 11. So 11 has only 2 factors, that is 1 and 11. So 1 will divide 11 and 11 will divide 11. So only 2 factors are there. So those numbers which have only 2 factors that is 1 and itself are called prime numbers, such as 2, 3, 5, 7, 11. 1 is not a prime number because 1 has only one factor, that is 1. Okay, so we have idea about prime number here. So now we are moving to all number one by one. So first we have started with natural number, then we move extension of natural number, that was integer, then we move to rational. So what was rational? So in the division portion we discover rational number. So then rational to, so we haven't studied about irrational and real number. Okay, so let us discuss about irrational number. So basically irrational number are those number which are not which cannot be written in the form of p by q, although all natural number, integer, rational can be written in the form of p by q. So rational number are those number which can't be written in the form of p by q, where p and q are integer. Okay, so natural number was denoted by n, integer was denoted by j, rational is denoted by q. So irrational number are like root 3, root 2 and root 7 as well as root 11. So we can't write root 3 in p by q form. So although we can compute value of root 2, so let us assume any triangle which have height 1 and base 1, so its hypotenuse will give value root 2, or we can assume 2 as base and 1 as height, so it will give root 5. So and so on, we can find this value, but we can't represent in the form of p by q. So these are irrational number, and the collection of rational index irrational gives real. Although professor also taught complex number, and he used one example, that is root over minus 1, that is equal to what. So basically complex number is not included in this portion, although you may have studied in standard 12th or 11th in the algebra portion, de Moivre's theorem, cube root of unity, although it is not required here. So we will not deal with here complex number. So basically we have idea about natural number. What are natural? The counting numbers, integer, the extension from left to right, that is minus infinite to infinite, or rational integer, then we move to rational, then irrational and real. So there are 2 points related to it, that rational and irrational. So basically sum of irrational will give irrational. Okay, although product can give rational. So let us take one example, that is root 2 plus root 3 and root 2 minus root 3. If we add these two irrational numbers, so it will give 2 root 2, and if we multiply root 2 root 3 and root 2 minus root 3, so it will give 2 minus 3 minus 1. So you may also use it for subtraction as well as division. So what will get there? So use your mind there. So now we are done with rational, irrational, and one thing is also there, that natural numbers are plus 1 and plus 1. So the consecutive natural number or the next natural number is 1 greater than the previous one, or integer as well. So if we consider 0 as natural number, then it's then next term or the next natural number will be equal to 1, and again it will be equal to 2 and 3, similarly for integer as well. So if we take integer 0, then in the next integer will be 1, 2, 3, but this particular case is not true or not hold valid for rational number. So let us assume two number, that is 1 and 2. Okay, so we are taking a huge gap there here. So 1 and 2. So but what we get here is we can generate infinite number of rational number between 1 and 2. So first we will generate add these two. So 1 plus 2 divided 2, that will give 1.5. Then we will divide here, so it will give middle point between 1 and 1.5. Then we will divide 1 and this middle point, then we will vary. So this will give infinite number. Okay, so very what will we say here, that is very closely packed. Okay, very closely packed number. So there are infinite numbers of rational number between any two rational number. So you have to remember this point also, that in integer the plus 1 is added to the next term, and but in the rational number, between any two natural number there is no natural number, only finite number of natural number are present, that is from 0 to 3 there are only two natural number. We can't compute 0 to infinite how many numbers are between there. So basically the general idea or the generic idea about it is, between any two natural numbers there are finite numbers. Okay, but between any two rational number we can generate infinite number of rational number. Okay, so those who have mathematics background, I think they don't have subscribed to this course, but you may have studied in the degree level that Newton method to find fourth degree, or Kutta method to find the fourth order. So what we will do there is, basically this type of operation are done in this form, this method. Okay, so we have a very good idea about natural number, integer, rational and real. So let me draw a Venn diagram here. So first we have started with natural numbers. So natural numbers is denoted by n, so let me write here n, and it was denoted by like this one, n naught. So the extension of natural number was integer, so integer was denoted by z. So the extension of integer was a rational number. Okay, q, and here it was irrational, and all the rational and irrational will make a real number. Okay, so you have to remember, or what will you say is, this is called real. Okay, so this is a real, so this is a real number. So basically the conclusion for all these topics for natural number and there is operation, rational number, real and complex number is ended here. Okay, so but natural number is the extension of natural number is integer, then rational plus rational will give real number. So you have to remember these points, that is so here you don't have to remember anything, just remember this, that 0 is included in natural number, quotient remainder factor, the quotient is represented by modulo, and what is meant by factor. Okay, and how we represent it, so representation is very important here. So the rational number, so what is GCD, and prime number, natural integer rational, and in the natural number we can also make one circle here, that is prime. Okay, so this is a representation of natural number and its operation and all the stuff related to natural number, integer and rational number, rational, complex. So outside it is complex number, so we don't have to study complex number in this particular course. Okay, so now we are done with these three topics. So now we are moving to set theory. Okay, so set is basically well defined set of well, what is mean by set? Okay, so set is a collection of well defined objects. Okay, so let me write here set, and let me use different color. So two important points about set is, in set order is not important. Okay, so order is not important, and the second one is Or the second one is repetition is allowed, means repetition is allowed means it means duplicate elements. Let me explain this by using one example. So let us assume any set A, that is 1 2 3 4, and any set B, that is 1 2 1 3 3 4 4. Okay, so this kind of set is allowed here. So B is also set, A is also a set. Okay, so order is not important and duplication of elements is allowed in the set. Okay, so now we are moving to the second term, that is cardinality. So let me use here, so that is cardinality. So let me erase some set, and so here cardinality of a set. So cardinality of a set means the number of elements. So number of elements in that set is called cardinality. So we have assumed that set A was equal to 1 2 3 4. So the cardinality of set A is equal to 4. Okay, so number, let us assume another set, that is B 2 3 7 9 and 12. So the cardinality for set B is 1 2 3 4 5. Okay, so now basically one representation is also there, that is let us assume any set A. So if there is written that x, small x belongs to A, that means x is element of A. So here we can write 1 belongs to A, also 2 belongs to A, 3 belongs to A, 4 belongs to A. Okay, so 3 is member of A, 4 is member of A, 2 is member of A, 1 is member of A. So you have to remember this point also. So what does it mean? So now we are done with the basic idea about set. So membership. So I have told what is meant by membership. So x belongs to A means x is member of A. Okay, so that means x will be in A. So this is the very generic idea. So in A it was 1 2 3 4, so we can write 1 belongs to A, 2 belongs to A, 3 belongs to A, and 4 belongs to A. So this was for membership. And for subset, so let me write here subset. So subset means, let us assume any set A, that is A B C D E. So let us assume any subset of A. So what it mean by subset? So subset means so subset of A means any set. Let's assume that set is X, and that is denoted by this sign. So X is subset of A if E of X is A B C D E. If X contain only A, or X contain A B, or X contain A C, or X contain A B C, so then we can say that X is subset of A. Okay, so X can be made using subset A. So that does it mean? Okay, so this is a very generic idea about subset. So there is a very one important point is also there, that when two sets are equal. So let me write one point here. So let us assume that set x is equal to set y. So it is only possible when x is subset of y and y is subset of x. That means let us assume x is 1 2 3 and 4 and y is also 1 2 3 4. So x can be made using y, or either y can be made using x. So both x and y are called equal set. Okay, so x is equal to y. So this was the idea about equality. Okay, so now we are moving to proper empty set and power set. So we will not hear empty set and power set here. Yeah, we are going to so we have taken idea about membership and subset. So there is one important point left here, that is proper subset. So proper subset means, let us assume x is proper subset of y. So this is denoted by like cut mark here. So element in x and element in y. So element in x will be less than y. So what does it mean? That is x can't be equal to y. So let us assume two set, that is y is 1 2 3 4 and x is 1 2 3. Then we can say x is power set, proper subset of y. Okay, or we can say 1 2 here x is, then we can say x is proper subset of y, or x is 1 here, then we can also say x is proper subset of y. So this was a very generic idea about proper subset. So basically it means proper subset means the set. Let us assume that we have assumed that x is proper subset of y. That means x will be never equal to y. So that is meaning of proper subset. So we have taken this example, either 1 or 1 2 or 1 2 3. This all can be said that x is proper subset of y. So we have very generic idea about proper subset here. So now we are moving to empty set and power set. So let me erase these points. So what is empty set? So empty set is denoted by phi and it means nothing, no element. Okay, and power set. So what is mean by power set? So power set means set of all subset. So earlier we have assumed a set, so we should constant our we should consider. So let us take one example and understand what is power set. So let us assume a is 1 and 2. So one point was missing here, that every empty set is subset of any set. Okay, so this is not the notation. So this is phi is subset of any set, that is x. So the first subset for a will be phi, then 1, then 2, then 1 and 2. Okay, and the set of all the subset. So this is called power set of a. So we can also take another example for 3 elements, that is a, b and c. So first it will contain phi, then a, then B, and then C, then two terms AB, BC, and CA. So there are 7 elements here, so now it will contain all these elements A, B, C. So this will be the collection of, or this will be the collection of all subset of A. So there are 8 elements here, so you have to remember only one point for power set is the number of, or the cardinality of a power set of any set is equal to 2 to the n, where n is cardinality of that set. Okay, so cardinality of parent set. So here in this particular example, let us suppose this one. So here cardinality for A was 2, so the cardinality for power set for a power set of A will be equal to 2 to the 2, that is equal to 4, and here 1 2 3 4 elements are there. Or similarly the cardinality of A is 3, so the power set of A will contain 2 to the 3 elements, that is equal to 8. So basically we can count here 1 2 3 4 5 6 7 and 8. Okay, so you have to remember all these points. So we have understood what is set or is not important, repetition is allowed, what is meant by cardinality. So here what is membership, what is subset, what is proper subset, what is empty set, power set, all these things. So set comprehension is basically writing a set in a more well-defined manner. So let us assume we want to write integers ranging from 50 to 60. We are not including 50 and 16. So how we will write? So basically we will write, so let us this set is denoted by A, so what we write here? So A is all integers, so let us assume integer is denoted by A is such that, so we will draw a vertical line here. So A belongs to Z, and A is such that it is greater than 50 and less than 60. So this is basically notation of this set A. So how we can write this set? So basically we will write, first we will go to all natural number, and the condition is A is greater than 50, so it will be 51. So it will go here 52, 53, 54, and when we reach 59, so we have to stop because it is not greater than 60 or equal to 60. Okay, so we can also generate some other stuff, like we want to generate numbers which are divisible by 7 and 9 both. Okay, so how we write? So all natural numbers, let us assume we want to write all natural numbers which are divisible by 7 and 9 as well. Okay, so how we write? So let us assume natural number is A here, so we will write A such that A belongs to natural number. Okay, and here it is divisible by both 7 and 9, so A modulo 7 is equal to 0 and A modulo 9 is equal to 0. Okay, so it is divisible by both 7 and 9, and we are not including 0 here. So first it will go, so it will equal to, first it will go to 63, because 9 times 7 will give 63, then it's a square. Okay, so basically this will go here. So how we can write in the set comprehension form? So there are many more examples in the lecture, so we are not going to cover all those here because it will be more lengthier. So now we are moving to set operation, the most important. So most of the question are asked from here. So what is mean by union, intersection, complement and set difference? So let us assume two set, that is A here, and let us assume set B here. So by making an example or by taking an example we can understand it better. Okay, so let us assume A contains 1 2 3 5 7 and B contains 7 8 9 and 5 as well. So what will be union? So union is denoted by like U. Okay, so A union B will be equal to, so we can give these numbers here. So what, so which elements is included in both A and B? So elements included in both A and B is 5 and 7. So we will write only one time here. So 5 and 7 will be written only once in A union B. So A union B is basically A plus B. Okay, and we will write the common elements for both A and B only once. So basically A union B will be equal to 1 2 3, and we will include 5 and 7, and we will not include 5 and 7 from this particular set, and 8 and 9. So basically the cardinality for A union B will be always equal or less than cardinality for A and plus cardinality for B here. So basically for cardinality of A was 1 2 3 4 and 5, and cardinality of B is 1 2 3 4. Okay, but cardinality of A union B is 1 2 3 4 5 6 7. Okay, so 4 5 6 7, so it is 9 and it is 7 if they both are disjoint. So let us assume this was the case A and B, and here 1 2 3 and 5 7 was there, and let us assume here only 8 and 9 was there. So basically A union B will give 1 2 3 5 7 8 9, and here it will be equal to 2, so it will give 7. So you have to remember this point at cardinality for the union. So for union, so it is always less than or equal to cardinality of for individual set. Okay, summation of individual set. So now we are done with union, so let us understand about intersection. So let me erase here. So intersection is basically the common to both one. Okay, so common to both. So we are interested in finding intersection for A and B. So intersection is written like downward. Okay, union was written upward, intersection is written downward. So but basically what we'll do here is we will find those common elements which are present in both A and B. So here only 5 and 7 are present, so intersection will be equal to 5 and 7. So in A intersection B will contain 5 and 7 elements here. Okay, so this part will be intersection. Okay, so now we are done with union and intersection. So the third concept is complement. Okay, so let me erase this. So let me erase all this slide. So we are interested in complement now. So complement means complement. So complement means completion. So let us assume any two set, that is A and B. So completion means A plus will give something. Okay, so we will find complement of A, that means excluding A what is left, and if you want to find for B, so what is B complement, so excluding B all those elements will be present in this whole portion will be equal to complement of B. Okay, so let us assume uh, this is prime number, and this is natural number, and this was integer. Okay, so let us try to understand what complements mean. So if we are interested in finding the complement of prime number, so prime number with respect to universal set natural number, so we are interested only at natural number level. Okay, so we are taking universal set at this boundary. So basically exclude, so complement of prime number means exclude prime numbers from the universal set, so all these will give complement. So basically we will remove natural number minus all the prime number. So if we are interested in finding complement of prime number with respect to integer, then this whole portion, okay, this whole portion will also be included in the complement of prime number. So it will be equal to complement of prime number will be integer minus prime number. Okay, so let us write this one. Okay, natural number minus prime number. So natural number here minus prime number will give 3, 2, 3, 5, 7 and so on. So we will subtract all these elements from natural number, then we'll give complement of prime number with respect to natural number, and we will subtract integer, we will subtract all prime number, that is 2, 3, 5, 7 from integer, then we will give a complement of prime number with respect to integer. So the fourth context for the fourth concept is set difference here. So let me erase here, and set difference. So set difference is denoted by like a and b. Okay, so set difference means a minus b. So basically it means all elements in a excluding b. So let us take one example here. So let us assume this was a and this was b. So we have assumed a was 1, 2, 3, 5, 7 and 9, and b was 7, 5, 8 and let us assume 10. So basically give this number here. So in the common portion it was 5, 7, 5, 7. Okay, so basically a minus b will give, remove all those numbers. Okay, so subtract all those numbers. So basically a minus b is equal to all elements in a excluding b, so that means that are not in b. So all elements in a that are not in b, so 5 and 7 is in b. Okay, so we will remove this number. Okay, 5 and 7. So a minus b will give 1, 2, 3 and 9. Okay, so here 1, 2, 3, 9, and this is 5 and 7, this is 8 and 10. And if you find b minus a, so all elements in b which are not in a, okay, so which are not in a is only 8 and 10, so it is 8 and 10. So from here we can conclude that a minus b is equal to is not equal to b minus. So basically a minus b is not b minus a. Okay, so you have to remember this point also. So now we are done with all the concept related to set theory, properties of it, operation, set operation. Now we are moving to word problem. So this was the most, so why we have done, so the most So this particular session, so basically we introduced this particular course, the qualifier session, for practice. Okay, so we will practice here a lot, that will boost your confidence. So we are moving to the word problem. We will start from very basic, that is universal set is 1 2 3 4 5 6 7 and 9, where a is 1 2 3 4, b is 2 4 6 8. So we have to find a complement, b complement. Okay, so this is universal set u, where a is here, so 2 and 4 is common to both. So here it is a and this is b. It is 2 and 4. Let me use different color. So 1 contain 1 and 3, b contains 6 and 8, and 1 is gone there, 2 is also gone, 3 is also gone, 4 also gone. So 5 is outside here, so 5 also gone, 6 also gone, 7 outside it, so 7 also gone, 8 also gone, and 9 here. Okay, so we have represented this in a Venn diagram. Now we have to find a complement. So a complement means excluding a, so we will remove all these numbers from the universal set. Okay, so we will remove 1 3 and 2 and 4, 1 3 2 4 from the universal set. So 1 3 2 4. Okay, so this will be left. So a complement will give 5 6 7 8 and 9. So now we are moving to find b dash. So basically b complement will give excluding b, so we will remove 2 4 6 8 from the universal set. So b complement will give, so remove 2 4 6 and 8. So b complement will give 1 3 5 and 7 and 9. Okay, so we have done 1 3 5 and 5 7 9. We can also conclude from here. So this was a very basic example how we can find a complement and b complement. So we are done with the first question. The second one is, given three set a b c such that x is a natural number between 10 and 16. So we will write a here. So a is natural number between 10 and 16, so it will be 11 12 13 14 and 15. B is such that set of even number from 8 and 20, so between 8 and 20, so it will be 10 12 14 16 and 18. Okay, so this is between 8 and 20. And C is 7 9 11 14 18 and 20. So we have to find a minus b, or this is dependent by this. So a minus b will be those elements which is in a but not in b. So a minus b, so find those elements which are both common to a and b. So here 14 is common, 12 is common. Okay, and no other elements is common. So we will write all those elements which are in a but not in b. So 11 13 and 15 are in a but not in b. Okay, so a minus b will be this one. So b minus c, we have to find b minus c. So all those elements which are in b but not in c, so we will exclude all those elements which are present in c as well as in b. So basically 14 is present, so we will remove 14, and 18 is present, so we will remove 18 as well. So the left elements are 10 12 and 16. So you have to keep your concentration high while solving this type of problem. So b minus c, so it means all those elements which are in b but not in c. Okay, which are in b but not in c. Okay, So 14 and 18 were in C, so we will exclude all these points. So you have to do all these two questions. Okay, so I have done these two questions, so basically you have to solve these two questions. So this particular question is from qualifier, so you don't have to earlier try to avoid it. Basically it is multiplication, so we will not so we haven't studied about relation here, but we can also solve this particular question by using some basic concept that we have studied in this particular session. So a is 4 5 6, b is 4 7 8, c is 4 6 7. So a minus b, so first we will find a minus b. So a minus b means all elements in a that is not in b, so we will exclude all those elements that are present in both a and b. So 4 is present here, so a minus will give 5 and 6 only, and b intersection c. So b intersection c means common to both b and c. Okay, all those elements which are common to both b and c. So common to both are 4, here it is 4 7 and 7. So this is 4 and 7. So now we can write a minus b cross b intersection c. So it is 5 6, and this is 4 and 7. So how we will write multiplication of two sets? So let us assume this is a and b, and this is b and c. So I will write a gonna b, so that is a b, and sorry, let us assume this is c and d, c and d. So this is ac. First we'll take this element and multiply with b, this and this one, so this will be ad, and then we will take this, so bc and bd. Okay, so this will give 4 elements here, so there are 4 elements also there, 2 1 2 and 1 2, so this will give 4 elements. Okay, so it will be equal to 5 4 5 7 6 4 and also 6 7. Okay, so we have to find the cardinality of this set. Okay, so cardinality of this set is 1 2 3 and 4. Okay, so we have to basically count the number of elements this particular set. So this particular set contains 4 elements. So this was a qualifier, this was asked in this qualifier October qualifier. Okay, so this was a quite basic one. So this was the application of set difference and intersection, so basically set operation. So now you have to solve this particular question. Okay, so you have to find both, you have to take first intersection, then find its complement, and you have to find a complement, then b complement, then take union, and whether these both are equal or not, so you have to verify it. So solve it. So now we are moving to the word problem, that is a and b are two finite sets such that n of a is 20. Okay, so cardinality of a is 20. So let us assume this is set a, so there are 20 elements in this set. Okay, and they are set b such that this include 28 elements. Okay, so set b includes 28 elements, and a union b is 36. Okay, so a union b is equal to 36. So basically I have already told you that cardinality of a union b is always less than the individual cardinality. Okay, summation of individual cardinality, here this is 20, this is 28, so it should be equal to 48 if both these set were disjoint. So but here it is 36, so that means it will share some here. Okay, it will share some portion. So let us assume this portion is t. Okay, so this will be equal to 20 minus t, and this will be equal to 28 minus t. Okay, so basically it is saying that a union b is 36. So basically 20 minus t and 28 plus t is equal to 36. So basically T and T will cancel here. So it was 28 minus T. So basically this is 48 minus T is equal to 36. So T is equal to 8. Okay, 48 minus, sorry, it is T is equal to 12. Okay, 48 minus 36 will give 12. So we have to find a cardinality of A intersection B. So cardinality for A intersection B is 12. Okay, so we have to find this portion. So we have already found that this portion will include 12 number. Okay, so we have solved this particular question. Now moving to the another one. So in a group of 60 people, 27 like cold drink, 42 like hot drink, and each person like at least one of the two drink. Okay, so this is 60 people. Okay, and 27 each fan of cold, and 42, so this is 27 and this is 42, and at least one of the two drinks. Okay, and each person likes at least one of the two drinks, so that means there is no person who doesn't like these two drinks. Okay, so this is 27, this is 42, and total there are 60 people. So how many people both like coffee and tea? Okay, cold drink and hot drinks means coffee is hot, I don't know, and tea. So let us assume this is not coffee and tea, so this is hot drink and cold drink. Okay, so we have to find this portion. So let us assume this portion is also t. So this portion will be 27 minus t. This is 42 minus t. So basically it will be equal to 27 minus t plus 42. Okay, so it will be equal to 60. So basically 27 plus 42 will give 69. 42 and minus t is equal to 60. So t will give 9. Okay, so 9 people like both hot drink and cold drink. Okay, so if we substitute 9 here for this portion, so it will be equal to 18, and this will be equal to 31. So 31 9 4 sorry, this is 33. So 33 and 9 42 plus 18 will give 60. Okay, so this is satisfying the condition. So this was the second question. So we have done it very easily. So the third question is in a group of 100%, so 72 people can speak English, 42 can speak French. Okay, so how many can speak English only? Okay, how many can speak French only, and how many can speak both language, English and French? So let us assume this is English speaking people and this is French. So total 100 people are there. So 72 people can speak English. Okay, this is 72, and 43 can French. So let us assume there are a number of person who can speak both English and French. So it will be equal to 72 minus a plus 43 will be equal to 100. So basically it will be equal to 105. 3 to 5 minus a will be equal to 100. So a will be equal to 15. So that means there are 15% who can speak both English and French. So it is asking about how many person can speak English only. So English will speak 72 minus 15, that is equal to 57 people, and only French will be equal to 43 minus 15, that is equal to 28. So we have done this question also. So this was only 2 variable question, so we will soon move to 3 variable. So I think this is the 3 variable question. So in a competition, a school awarded medal in different categories: 36 medal in dance, 12 medals in dramatics, and 18 medals in music. Okay, so this is 3 variable question. So let us assume this is dance, this is drama, and this is music. So let me use different color here. So 36 medal for dance, 12 medal for drama, and 18 for music. Okay, so if these medals went to total 45%, that means this medal will be equal to 45, and only 4% got the medal in all 4 categories, so this is equal to 4. So it is asking about how many received medals in exactly 2 of these categories. Okay, so exactly 2. Okay, so exactly 2 means this portion and this portion and this portion. Okay, so let us assume this portion is x, this is y, and this is z. Okay, so here the dance will give x minus y and minus 4. This will give 18 minus z minus y minus 4, and similarly drama will x minus z minus 4. Okay, and this will be equal to 45. So add all these things. Okay, so 36 plus sorry, let me use different color. So it is equal to 36 minus x minus y minus 4 plus x. Okay, so this one plus 4 plus y. So we are done with here. Now we are writing for this particular portion, that is 18 minus z minus y minus 4 plus z. Okay, so we are now done with here. So this was z and this is remaining one, so that is 12 minus x minus z minus 4. Okay, so now we are done with all. So this is equal to 45. So add all these things. So basically x will balance here, z will balance here. Okay, and any other things that is left, so y will also balance here. Okay, so y will vanish, so only 3 here left. So 36 and 18 will give 54 and 12, that is 66. Okay, minus, that is 4 4 4, that is minus 12, and this 4 will balance this 4, so it will be equal to minus 8. Okay, so now we are done with 4, and minus x plus y plus z will be equal to 45. So that means 66 minus 8, so it will be equal to 58. Okay, so 58 minus 45 will be equal to x plus y plus z. Okay, so x plus y plus z will be equal to 13. Okay, so there are 13 people, so there were 13 medals in exactly 2 of these categories. Okay, so it was particularly asking about x, y and z, so we have found that it is equal to 13. So this was a very good question. So the next question is, in a class 50 students play cricket, 35 play football, 14 play both, 9 play neither. Okay, so this is some kind of disjoint. Okay, so let me erase here. So this is a particular class, so 15 students play cricket, so this is cricket, and this is 50 students, this is football, and 35 play football, and this particular area constitute of 14. Okay, so this 14 students play both cricket as well as football, and 9 play neither. Okay, so 9 is here. So how many students are there in the class? So we have to find how many students are there. So only cricket will be 36 and only football will be 21. Okay, so there will be 36 plus 21 plus 14 plus 9 students will be in the class, so this will be equal to 36 plus it will be equal to 35 plus 9, so it will be equal to 71 plus 9, that is equal to 80. Okay, so 36 21 14 it will give 35, and this will give 71 plus 9, so it will be equal to 80. So there are 80 students in this particular class. So the another question is, a group of 25 people are planning to get together to celebrate their 10-year of friendship. So okay, out of them 9 suggested to Goa. So let us assume this is Goa, and 9 people suggested to go Goa. Okay, 8 suggested to go Bangkok. Okay, so 8 is suggesting that we should go to Bangkok. Okay, and X suggested to go to Pondicherry. So this is Pondicherry, and X people are suggesting here, and 3 of them didn't suggest anyone, so 3 are here. So consider each person suggested only one place. Okay, so each person is suggesting only one, so any person can't suggest two. Okay, so what is the value of X? So we have to find the value of X. So how many people suggested Pondicherry? Okay, so this constitute 25 people. Okay, so it will be equal to 9 plus 8 plus 3 plus x, so it will be 9 plus 3 plus 8 plus x will be equal to 25. So basically it is equal to 17 plus 3, that is 20, plus x, that is equal to 25. So x is equal to 5. So in this particular type of question, you have to draw a Venn diagram. So if you are successfully drawing a Venn diagram for this particular question, this type of particular question, or so you can easily solve this question. Okay, so this particular question was in the practice assignment, so we will try to solve it here. So this particular question is, let S1 be the set of irrational number between 0 and 1. Okay, and S2 be set of rational number between 0 and 1. So the S1 is irrational number set of irrational 0 to 1. Okay, and S2 is set of rational from 0 to 1. Okay, so 0 and 1 is including here, and S be the closed interval 0 to 1. Okay, so S will be equal to S1 plus S2, because set of rational and irrational from 0 to 1 will give S. Okay, so which of the following options are correct? Okay, so let me draw here one number line. It is 0 and it is 1, so there may be irrational number in between, and there are rational number. So 0 and 1 are rational, so irrational and rational will give all the real number between 0 and 1. Okay, so if we add S1 and S2, and this S will give set of a real number between closed interval 0 to 1. Okay, so now moving to the option. So S1 and S2 will be an empty set, so S1 and S2. So irrational number in the so previously we have studied a rational and irrational are disjoint set. So basically the intersection will give empty set. Okay, so that's true. So if two sets are disjoint, that means they doesn't share any area. So let us assume this is A and B, and A and B are mutually disjoint. That means neither A neither B share area with each other. So that means intersection will be nothing, and nothing means empty set. Okay, so S1 and S2 is an empty set, so that's true. S1 intersection S2 will be S, so S is basically set of real number between 0 to 1. So here, from here we can conclude this point also. The third is S1 union S2 is a proper subset of S. So proper subset means not equal to, but S1 and S2 is equal to S. So this statement is incorrect. S2 is a finite set. Basically there are infinite number of rational number between 0 and 1, so this is also incorrect. And the last one is S minus S2. So S is equal to S1 plus S2, so S minus S2 will be equal to S1, so this is also correct. So this question was asked in the practice assignment. So this was a very good question, that's why I have taken this. So this question was asked in, I think, in the practice assignment. So this question is: a study is conducted at a factory manufacturing chemicals C1 and C2 yielded the following results. So if a worker is exposed to either C1 or C2 but not both, then the worker is at low risk of developing skin disorder. That means if a worker is either working in C1 or C2, then it will have low skin disorder. Okay, so he will not feel any harsh impact of chemicals. However, if the worker is exposed to both C1 and C2, so let us assume there are some workers who are both exposed to C1 and C2 here, then he is a high risk of contracting the skin disorder. Okay, so if out of 150 workers, so there are 150 workers in the factory and 120 are exposed to C1, so here it is 120, so total here 120, so this whole is C1, and 90 are exposed to C2. Okay, so this whole is C2. Then how many workers are high risk of developing a skin disorder? Okay, so here it is asking about this common portion. So let us assume this is A, so it will be equal to 120 minus A, and this will be equal to 90 minus A. So the sum of 120 minus A, 90 minus A, and A will give 150, so it is equal to 210, and minus 2A plus A will give 150, so it will give minus A, so A will be equal to 60. Okay, so there are 60 workers who are exposed to both C1 and C2, and they will have very high impact of chemicals on their skin. So there are 60 workers. So this was also asked in the practice assignment. So moving to the another one, so you have to do this question. Okay, so this is basically set comprehension. So by doing this question we will be able to understand set comprehension very. So I think this question was also asked in practice assignment. So in a town consisting of 1 million people, 1 2 3 4 5 and 6. Okay, so 85% of the people speak Hindi. So this is Hindi, and 85% people speak this language. 50% speak English, so this is 50%, and this is English. 40% speak Bhojpuri, so this is Bhojpuri, and this is equal to 40%. So also 20% speak Hindi and English only, so this area Hindi and English only, so this area. So this is 20%. 30% speak Hindi and Bhojpuri only. Okay, 13% Hindi and Bhojpuri, so this area. So this is 13%. Let me write outside here. And 10% speak English and Bhojpuri only, so this area. So this is 10%. How many people speak only one language? Okay, so we have to find this area, this area, this area. So let us assume this is A%. Okay, so how many people will speak only Hindi? So it will be equal to 85% minus the 20 and 13, that is 33%, minus A plus this area, so it will be equal to 50 minus 30% and minus A plus, for this one, so it is 40% minus 23% minus A. Okay, so and finally we will add this area, so it will be equal to 33% and plus 10%. Okay, and plus A, so whole will constitute 100%. So subtract, so A will balance A, plus 33% will balance 33%, and there is any 10% here, so no, there is no any 10%, so add all this, so 85% plus here 20% plus here 17% and minus 2a, and this is 10%, so it will be 30% will give 100%. So basically it is 115 and 17%, so that is 132% minus 2a is equal to 100%. So a will be equal to 32 divided by 2, that is 16%. So here a is 16%, so that means this portion will be equal to 85% minus. So basically we have to find how many people speak only one language. So when we subtract this portion and this portion, we can easily find this, okay, by subtracting from 100%. So let me write here, use different color. So this is 16, okay, so 100% minus 20 plus 13 plus 10, and this is 20, 13, 10, and a was equal to 16. So it will be equal to 100 minus, so this is 33, 43 and 16, that is 59. So it is equal to 41%, and 41% of 1 million. So basically it is 4,10,000 people. 1 2 3 4 5, okay. So 4,10,000 people speak only one language. So this question was asked in the qualifier, October qualifier. So in a school, out of 400 students, 300 students opted for at least one subject. I don't know this particular question was asked in qualifier or not, so I think it was asked. So out of 400 students, 300 of students opted for at least one subject out of bio, chemistry and mathematics. So let me write here. So this is bio, this is chemistry, and this is maths, okay. So 300 students, okay, opted for at least one subject. So 120 students opted for bio, so here it is 120. 150 opted for chemistry, so 150 here. 200 opted for mathematics, so that's good. And 30 opted for all these three subjects, okay. So here this is 30. So we have to find the number of students who opted for exactly two subjects. So there was 400 students, 300 opted for at least one subject, okay. So this means this will constitute to 300 and 100 students neither opted for at least one, so they are well up people, okay. So this will constitute 400. So basically this will give 300. So let me erase this line. So let us assume this is x, y and z. So what we have done previously, this was the same question, I think. So let me I think this was the same question I have solved earlier. So this was the same question, okay. So this was the same question based on this pattern, so you have to solve that particular question. So by doing that you will gain confidence at this question, okay. So we will gain confidence in shared theory. So this particular session will be very long, I think, and I think so basically how you can get maximum through this session is just watch the lecture, just watch lecture provided by the professor, then watch these lectures, and what you have to do is the question that I have solved, the questions that has been solved in this session, you have to solve it again. Okay, so you have just to take a screenshot of it, and let us assume you have watched this lecture in the morning or evening. So what you have to do is after 12 hours you have to solve this question again. Okay, so by doing this, uh, if you are able to solve this particular question, then that's good. If you are not, then watch these lectures again and again. So this was a very brief, so I think this session will be very long, so we should end here. So thank you, and have a nice day. So in the subsequent session we will be dealing with a relation, types of relation, and a very generic idea about function. So thank you again, and enjoy your weekend.